Okay. Then this other region, these other elements which are shaded red, this one is here, are non-metals. Therefore, which oxides do they form? They form acidic oxides mostly. However, there are some of these non-metals which will form neutral oxides. For example, we have carbon. Carbon can form carbon monoxide, which is a neutral oxide. We have nitrogen, which can form nitrogen monoxide, which is also a neutral oxide. Then we have over here hydrogen. Hydrogen is also a non-metal, and it forms a neutral oxide, which is called water. Okay? Then you realize that this group of elements has no oxides. Why does it have no oxides? These are group 8 elements which are not reactive. Therefore, they don't form oxides. Okay? Apart from one which is slightly reactive, that is xenon, which is able to form an oxide. Okay? Good. Now, there are other ways of categorizing oxides. We can categorize oxides in 3 groups, which are just other ways of categorizing. One is normal oxides. Normal oxides are all those other oxides we have looked at: basic oxides, acidic oxides, amphoteric oxides, neutral oxides. Those are normal oxides, meaning that they have just oxygen combined with another element in the stoichiometric proportions. Then we have mixed oxides. Mixed oxides are oxides which have chemical properties like a mixture of 2 or more normal oxides. Okay? So it behaves like it is made up of 2 normal oxides. For example, we are going to look at a triion tetraoxide, which behaves like iron 2 oxide and also iron 3 oxide. Then we have peroxides. Peroxides have twice more oxygen than the normal oxides. That means that if the normal oxide has 1 oxygen atom, then the peroxide will have 2 oxygen atoms. Okay? Good. So let's look at these oxides one by one, starting with basic oxides. Now, basic oxides, we said, are metal oxides. But we said that not all the metal oxides are basic oxides. Remember that. Therefore, we have some examples here of basic oxides. Magnesium oxide, and its formula is there. Take note that this is capital M, lowercase g, and then capital O. Then we have sodium oxide, its formula is there. Calcium oxide and copper oxide. Look at this. You realize that in all cases, one of the elements is a metal and the other is oxygen. So a metallic oxide or a metal oxide contains a metal combined with oxygen. Okay? Very good. Now, something very important to note. Please note this, that basic oxides react with acids to form a salt and water. Please write it somewhere and never forget. Basic oxide plus an acid, you form a salt and water. Depending on which oxide you are dealing with, the salt will be different. For example, you have magnesium oxide. When it reacts with hydrochloric acid, you will form magnesium chloride, which is the salt, and water. Okay, so the equation is here: magnesium oxide plus hydrochloric acid to form magnesium chloride and water. This kind of reaction is called a neutralization reaction, as you will study about. Okay, now basic oxides do not react with bases. Note that again. Basic oxides do not react with bases. Let me give a funny illustration. Human beings normally are not supposed to hit human beings. Men are not supposed to marry men because they are of the same category. Therefore, basic oxides are not supposed to react with bases. They are of the same category. Okay? So, when you see a base plus a basic oxide, the product is nothing. No reaction taking place because they are of the same category. Now, if a basic oxide is able to dissolve in water, meaning that there are some that are not soluble in water, but for those that are soluble in water, they are going to form alkaline or basic solutions. They are basic oxides, therefore they will form alkaline or basic solutions. So the solutions can be called alkaline solution or basic solution. A basic solution turns the color of red litmus paper to blue. Look at this. This solution in this container is a base. It is a basic solution or alkaline solution. Now, when you dip this red litmus paper into this solution, look at the portion which is inside the solution. The color of that red litmus paper has changed from red to blue. That is how we test whether the solution is alkaline or basic. Okay? But when you on the other hand dip a blue litmus paper into an acidic solution, as we shall look at, the color of the blue litmus paper turns to red. Okay? That is very important in practical, so you please master it. Okay, then let's look at acidic oxides. Acidic oxides are non-metal oxides. We also call them acid anhydrides. An acid anhydride, like we defined, is an oxide of a non-metal which reacts or which dissolves in water to form an acid. Okay? Examples we have looked at: carbon dioxide, sulfur dioxide, sulfur trioxide, nitrogen dioxide. All those are acidic oxides. Now, when they dissolve in water, when an acidic oxide dissolves in water, the solution formed is an acid. And therefore, because the solution is an acid, it turns the color of blue litmus paper to red, like we looked at before. Over here, we saw that this solution is an acid, right? When you dip this blue litmus paper into this solution, look at the portion inside the solution. The color of the blue litmus paper changes to red. That confirms that the solution is acidic. Note again that things of the same category do not react. We said bases do not react with bases. Therefore, acids do not also react with acids. So two acids cannot react with each other. Only acids can react with bases, but acids cannot react with acids. Okay? Then we say that acidic oxides dissolve in water to form acids. For example, sulfur trioxide, when you react it with